So in this video we're going to perform partial fraction decomposition of this complicated looking fraction here. We've got a polynomial in the denominator and a polynomial in the numerator, and we're going to try and break that into its components. So our denominator here, we've got x squared plus 1 and x squared plus 4. So those three terms there are all quadratic. Now Heaviside cover-up method here is not going to work because we've got quadratics. So what we need to do is to break this apart into three quadratic terms with constants to be found in the numerators. So we'll set it up like this. So denominators will have x squared plus 1 and x squared plus 4. So that's those three terms there. Now, as these are quadratics, the numerators here, we need more than just a constant. We'll need two constants to find because we'll need a linear term in the numerators. So if I set that up as Ax plus B and two new variables here, so that gives me Cx plus d, and two new variables there. This time I'm going to use E and F. So this time Ex plus F. Okay. Now, the next thing is I'll need to multiply both sides by this term here, thus getting rid of this term on the left hand side, and then this side here will have some variations with this in the numerator. Before I can do that, I'm going to need to multiply out my numerator on the left hand side. So let's take care of that. So here, if I just fall out minus squared times all of that, I'll have minus x to the 4 minus 4x squared, and then multiply that with 3 minus x plus a 4 minus 5x squared. Now notice this one here, I can just take away the brackets with a plus sign here, so that'll be fine. But I still need to distribute this 3 minus x with this term here. So now I'll have minus 3x to the 4. And 3 times minus 4 is minus 12 and an x squared. So now the minus x will be distributed. That'll give me x to the 5. And this one give me 4x cubed. Okay. Now if I take this one out of the brackets, I'll just add 4 and minus 5x squared. I'm going to come to this denominator in a moment. I'm just going to write the numerator out as it is. So now just simplify it off. We've got two x squared terms here. So now put them in order of indices. X to the 5 minus 3x to the 4 plus 4x cubed. And minus 12 minus 5 minus 17. And then I've got no x on its own, no x indice 1. But then I've got a plus 4. Okay. Right, so that's what I've got there. Now if I'm going to multiply both sides by this denominator is now going to disappear. So that takes care of that, just leaving it as it is. Now here I've got, write this one out, I've got Ax plus B, put that in a bracket, you'll see why in a moment. And then same with this one here, put that one in a bracket. And the last one as well, likewise. Put that in a bracket. Okay. So now if I multiply each one of these terms with this term here, one of them is going to cancel out. It corresponds with our denominator. But the denominator is also going to disappear. So if I multiply this by this term, the x squared will disappear and I'll be left with x squared plus 1, x squared plus 4. So if I just write that up above there, x squared plus 1, x squared plus 4. Okay, now this one here, I've got x squared plus 1, so that will cancel out my denominator. And I'll be left with x squared plus 4. So x squared plus 4. And the same with this, the x squared plus 4 will disappear and I'll be left with these ones. So now I've got x squared plus 1. Now I need to multiply these terms here with its corresponding, like my building blocks from the first line of working. So this is looking quite complicated. What we'll be able to do, once we've done that, we'll be able to set up a system where we can do corresponding coefficients and then solve for those variables. Okay, so now the left-hand side is taken care of. We'll just leave that as it is. We now need to FOIL out these terms here. So x squared plus 1 times x squared plus 4, that will give me x to the 4 plus 5x squared and plus 4. So that's that one. This one a little bit simpler, x to the 4 plus 4x squared. And this one, very similar, x to the 4 but plus x squared. So that's those ones calculated. Okay, so now all we need to do is multiply this one with this one. So let's go through that. So now ax times all of that. So I'll have an a, let's take that out, and then multiply the x with this. So that's just going to raise all the powers by 1. So I'll have x to the 5 plus 5x cubed plus 4x. Okay, now I need to multiply the b with all of that, but that just stays in the form it is because there's no x next to the b. So now I've got x to the 4 plus 5x squared plus 4. Okay, now let's take care of this one. So now to do cx times all of these. So as I did before, I'm going to add c times and then x times that, which will give me x to the 5 plus 4x cubed. Okay, the d needs to be multiplied by this one. So I now add d times x to the 4 plus 4x squared. So that's all that taken care of. And now this one with this one. So again, I'll do the e, multiply all this by x, which gives me x to the 5 plus x cubed. And then my f just with that one. Okay, right. Now that looks really complicated for doing corresponding coefficients, but what I'm going to do now is bring out each of the indices of the x and find the corresponding coefficients to go with it. So my setup on the right hand side will now look like x to the 5 and then put in all the corresponding coefficients inside the brackets. So I'll have an a, I've got a c here and I've got an e here. So a plus c plus e. And now let's have a look at the x to the 4 and find that one's corresponding coefficients. So now I've got a b, a d and an f. They've all got an x to the 4 term. So b plus d plus f. Okay, now x cubes. Now x cubes again, we're looking on this side. So now I'll have 5a, I'll have 4c and a single e. So 5a plus 4c plus e. Okay, right, x squared terms. So plus x squared. So again on this side, so I'll have 5b, 4d and a single f. So 5b plus 4d plus f. Okay, now x, there is only one term here with an x. So that will be 4a for the x. So that's the only one there. And for a constant, there is only one constant. So that goes with the b. So that's just plus 4b. Okay, right. Now that is set to be equal to this one. So I've now got x to the 5 minus 3x to the 4 plus 4x cubed minus 17x squared plus 4. So now the corresponding coefficients of each one is set up nicely to give me the value of that coefficient. So x to the 5, I'll have a 1, x to the 4 minus 3, x cubed and minus plus 4, x squared and minus 17, and then a plus 4. So that takes care of that. So let's make some space on the board, bring this up to the top, and then we've got something we can work with, and let's solve for these corresponding coefficients. Okay, so let's work this out. X to the 5, the coefficient for that is just 1. So a plus c plus e should equal 1. So a plus c plus e, that equals 1. X to the 4, I've got b plus d plus f. The corresponding coefficient for that one is minus 3. So b plus d plus f should equal minus 3. Okay, now x cubed, so a, c and e. So I'll put them on this side. So I've got similar coefficients on each side. So 5a plus 4c plus e, that should equal plus 4. Okay, now x squared. So this one here, b, d and f. So I'll write them out on this side. So 5b plus 4d plus f should equal minus 17. Okay, now what about the single x? So 4a should equal the single x coefficient, which should be 0. So that's worked out really nice for us. 4a should equal 0. So obviously we can see that a is 0. So let's put that up here as our first solution. So we already know one of our terms. And then we've got 4b, which is the constant, which should equal 4. So 4b should equal 4. So again, that's worked out really nicely. 4b equals 4, b is just 1. So we've already solved for our first building block here. So ax plus b, so 0x plus 1. So a is 0 and b is 1. So that's already taken care of. Right, so now we know some values here, so let's plug them into our equations here. So if a is 0, these terms here can all cancel out. And if b is 1, we can just change this to b is just 1. So that can just become a 1, and that can just be left as a 5. Okay, right, let's take these off the board. Okay, now we've got to do something with these equations here. So first of all, on this side, what I'm going to do is, instead of bringing my 1 across to here, I'm just going to subtract one equation from the other and get the f to disappear. Straight away, I'll isolate my d. So if I subtract them, so 1 minus 5 is minus 4. D minus 4d is minus 3d. And f minus f, that disappears. And then I've got minus 3 minus 17. So that's going to give me plus 14. Okay, so now minus 3d, add 4 to both sides, that's going to give me 18. So therefore d equals minus 6. So there's another coefficient there we've got. So if d is minus 6, I can calculate what my f is. So now using this equation here, that's the easiest one to use, I've got 1 plus my minus 6 plus f equals minus 3. So 1 minus 6 is minus 5. Minus 5, to get it on there, add 5 to both sides. So now I will get f equals 2. So that's solved that one. So f equals 2. Okay, let's write these in. D equals minus 6, f equals 2. Okay, what about this side? Well, this one's fallen really handy. I can just subtract straight away and get rid of the e. So c minus 4c is minus 3c. E minus e disappears. 1 minus 4 gives me minus 3. So therefore I can see if minus 3c equals minus 3, c is going to be 1. So c equals 1. Okay, right. Now if c equals 1, I can plug that into there. So then I'll have 1 plus e equals 1. So therefore e equals 0. Okay. So that one there is also 0. Okay, right. Let's take this off the board and then let's fill in our result for our partial fraction decomposition. Okay, so we've got the result of our corresponding coefficients. So a is 0, we've got 0x, that disappears, and then we've got a 1. So 1 over x squared. So we've got 1 over x squared. Here we've got c is 1, d equals minus 6. So therefore we're going to have to add x minus 6 over x squared plus 1. So it takes care of that. And here we've got e is 0, so therefore that's disappeared, and then we've got a 2. So now we add 2 over x squared plus 4. Okay, right, that is good enough for our answer. So that's our partial fraction decomposition of this very complicated looking polynomial fraction. Okay.